Hello, we are going to now look at trying to integrate various powers of the secant, the trigonometric secant function. So we'll begin with the first one in this video, and then in the subsequent videos we'll do various powers of secant. To integrate, or to find the integral of secant theta d theta, we almost have to work at it in a sense backwards by looking at derivatives of the trigonometric functions tangent and secant. So let me go ahead and start with the first of those. So let's try to find the derivative of tangent. I can write it that way. And in order to do this, we remember that tangent is the quotient of sine theta to cos theta. And speaking of the quotient, we are going to use the quotient rule that you've probably learned in calculus, which essentially says that u over v, the derivative of that quotient, is going to be u prime times v minus v prime times u all over v squared. Okay, so in this case, we can see that sine is acting like the u in the quotient rule, and so we get sine theta, its derivative, times cos theta, minus cos theta, its derivative, times sine theta, and then we divide this by cos theta squared, and when we go ahead and work this out, we see that sine theta's derivative is cos theta, and in fact we have cos theta then times cos theta, that's cos squared theta, minus, now cos theta's derivative is minus sine theta, so we have a minus times a minus sine theta, that becomes a plus, so that sine theta times that sine theta is then a sine squared theta over cos squared theta. And you probably recognize that on the numerator you have here a 1 from the trig identity, that sine squared theta plus cos squared theta is 1. And if you'll also remember that 1 over cos is secant, so we could then finally say that in conclusion then that the derivative of tangent of theta is equal to secant theta. And this is one of those things that you would do well to just basically memorize. Of course, you can rederive it the way we did it using the quotient rule, and if you ever forget it, then that's always a good thing to remember, but it would even be better if you just commit that to memory. Then let's look at doing the derivative of secant of theta. Okay, so, well, the derivative of secant of theta is 1 over cos theta. I can write this as, we can once again do the quotient rule, but just to show you a different way of looking at that, I can write this as cos of theta to the minus 1 power, and then I'm taking its derivative. So that would mean that I get, if I use the chain rule, I'm going to get minus 1 comes out in front, then I get cos of theta to the minus 2 power times, of course, what's inside. That's the chain rule part, which is minus sine of theta. And so you find that this is equal to a minus times a minus, then that is plus, so we get sine of theta over, let me write it this way on the bottom, cos of theta times 1 over cos of theta, because we have actually cos squared theta on the denominator. And you'll recognize that the first of these is just tangent of theta, and the second is once again secant of theta. So when you're actually taking the derivative of secant of theta, you see that secant of theta's derivative involves secant once again times the tangent. Okay, So once more, it would be good to memorize both of these. Now, having done that, when you come to try to figure out how to integrate the secant of theta d theta, the trick then is to, you might not see this right away, but if you were to rewrite this as secant of theta times, now I'm going to do a little trick now that we've done all the derivatives, secant of theta plus tangent of theta divided by secant of theta plus tangent of theta d theta. And if I distribute this, of course, I get the integral of, on the top, secant squared theta plus secant theta tangent theta. Well, that looks familiar. We did that down here. Divided by secant of theta plus tangent of theta d theta. And now we see a couple things that look familiar. One is that secant squared theta was the derivative of tangent theta, and secant theta times tangent theta is the derivative of secant theta. And so if I were to do a u substitution, namely, let's let u be the denominator, that is to say secant of theta plus tangent of theta, and then I get that du with respect to theta, the derivative of u with respect to theta is, the derivative of secant theta we know now is secant theta tangent theta, plus the derivative of tangent theta we now know is to be secant squared theta, and wow, lo and behold, that is in fact the numerator. Okay, so I can write all this as simply this is equal to the integral of du, that's all the numerator, and the denominator we said is u. So the complicated, at least complicated looking integral of all the secant theta times secant theta plus tan theta over secant theta plus tan theta, that reduces to the integral of du over u, and we recognize immediately that this is the natural log of the absolute value of u, and then we also pick up a constant of integration there, c, and if I sub back in what u is, then I see that, therefore, the integral that I was after originally, which is namely the integral of secant theta d theta, is equal to the natural log of the absolute value of u, but u is, in terms of theta, secant theta times tangent of theta, sorry, secant of theta plus tangent of theta, okay, plus of course that constant of integration. Okay, so now we have a very useful formula for the integral of secant theta to, of course, to the first power. Now in subsequent videos we will look at different powers of that. Okay, so I hope that was helpful, and join me in the next video where we look at trying to integrate the square of secant of theta d theta. See you there.